attending any conference, it's incredibly important to be there. That's kind of the only way to really dedicate your time to be there and kind of be immersed in the whole thing and not distracted by other stuff going on, even if you do get distracted with interesting conversations in the hallway.
Who wants to hear a joke on C++ reflection made by ChatGPT? That's not the actual joke. So the actual joke goes, a C++ reflection walks into a bar. And the bartender goes, what's he gonna be? And the C++ reflection says, what do you got? That was the joke. All right, I see there's still a ways from stealing our jokes. But actually, the joke does have a profundity to it because the reflection returned the question. So there is something to it, right? But then a joke explained is not a good joke. So for those of you who have a few more other talks to consider at this very time, I'll give you the punchline, then you can just go. So, static reflection, of which we've already heard a fair amount this week, without the code generation part is not complete. It's just contemplation, hence the title. The reading part of reflection is generally agreed upon. People have an understanding of why it's needed, etc., etc. But the generation part is actually not very much paid mind to. So it's a bit the Cinderella of reflection. And it's pretty much half of what you want to do with reflection. You want to read code, but you also want to be able to generate code, so have leverage. Without generation, there's no leverage. Without leverage, there's no nice things, right? So in closing, I will also talk a bit about AI and how it fits within this crazy picture of C++ and reflection and everything related. So we have this circularity interesting problem. By the way, those of you who want to go to other talks, you can go now because I gave the punchline that's everything there is in this talk. We have this weird circularity problem in reflection whereby you reflect on something with this double caret thing, which in the recent past was a single caret. And you reflect on something, and then you say, oh, let me actually unreflect on that stuff. And there's this nice identity that you reflect and unreflect on something, you get back the same very thing. X in this case can be pretty much any C++ entity, a declaration, and the name of a template, the name of a type, the name of a variable, pretty much anything that you can think of as a C++ entity. There's a consensus that actually doing this kind of stuff with the double caret is great. And there's also a consensus that actually getting back what you had reflected is also great. But there's fear and loathing about code generation. Whenever people hear about code generating code, like, whoa, wait a second. So, there's a lot of pearl clutching there that's quite understandable because it's something that's not quite precedent in C++. So as a consequence, there's very little we can do. I mean, besides the enum to string example. And by the way, let me rant about it a bit. Shall we retire for all eternity the enum to string example? Please. Like nobody should ever discuss enum to string as an example of reflection. It's like the littlest thing and the least interesting thing that can be done with reflection, my friends. Who knows about Lascaux, France? The caves, 20,000 years old. Thank you very much. 20,000 years old cave paintings. Some of the oldest in the world. They had there on those paintings how you do enum to strings with macros. Okay? I knew that, we all knew that how to do with macros, with a variety of things, all the way down to handwritten code. Thank you very much. We know how to do that. And by the way, command line parsing is not much better. I know how to parse command line with, I wrote myself a couple of libraries, and I can use the 15 others that I found on GitHub. You know, all reflection does is figure out what the name of things are. And that's not leverage. I want leverage. I want to write one line of code and conquer the world. What a great pull-out code. I keep that for the video, right? The C++ conference. One line of code will conquer the world, or destroy it, as it were. So there's no clarity on how to do these things. The generation part, you know, where do we start? How do we stop? How much code generation is enough? And let me kind of tell you like the big picture here, which is where do we want to be in the history of paradigms of programming? And we've had historically the classics, right? We have procedural programming, which was awesome because we got to write functions and call them. And everything was good, right? Remember the days like Fortran. You wrote a function and you called it, and you were really happy, right? It was a simpler time. With OOP, we actually got to call functions that have not been written yet. And that was something like weird. Wow, how come? Right? So that's OOP, because you get to override things, and that's all about OOP, is you call function into code that has not been written yet, and people come later and customize stuff, and you know, all of this open closed and all the good things, and right? So that's OOP, right? With templates, it gets even better because I can design with entire types that have not been written yet. I can have a vector of things that the thing has not been written yet, it's gonna be written later, and as long as it conforms to a certain interface, I can have a vector of that thing, which is pretty awesome. I mean, come on, right? Or I can sort a collection of things that not only I don't know what they look like, I don't know how they compare, I don't know how to iterate them, etc. And as long as you have the right interfaces in place, iterators and all that jazz, I'm in good shape. I know how to sort that stuff. So that's pretty awesome. Where can I go with reflection? Let me take this as a quick quiz. Who thinks they can write a one-liner that follows? You know, what's the next in the pattern of evolution? Reflection. I can customize types that were not meant to be customized. That wasn't a joke, really. I'm glad it landed, but it wasn't meant to be a joke. I can customize stuff that was not I can hash things written without the person written that type thinking it's gonna need to be hashed. I can serialize stuff without the person writing that stuff having written it with the intent of it to be serialized. I can do a lot of stuff because I get to X-ray that thing, inspect it, introspect it as it were, and making sure that whatever exceptions and whatever changes and whatever tweaks I want to do, I can do by means of code generation. Now, I'm not sure if it's obvious, but I'm not a native English speaker. That didn't land. Okay, so I gotta figure out what. We don't believe you, thank you. But I did a bit of a grammatical, I took a grammatical risque step here. I please native speakers, will not have been written for, will not have been. And that's, I don't know, how do you call it? Sorry?
The future subjunctive.
Thank you very much, the future subjunctive. So I'm using, you know, because I want to not talk about types that have not been written yet, but will not have been, so in the future, and people in the future will not design this for the kind of customization that I want to inflict on this type. So that's pretty much the basic idea. That's what reflection is for. Now, let's work with a simple example first, kind of get our feet in the water a little, get used to it, and then we're gonna go again back to the big picture. And the small picture would be I want to define a property. And I already, I mean, if I were in the audience right now, I would think, what an idiot. Property is an anti-pattern. Everybody knows. Like a property with a getter and a setter that just gets and says the thing, that's like a public variable. And as we know, nobody likes public variables because reasons, right? On the same token, however, this is a good start for a lot of good things. So first of all, remember Herb's example, Monday morning, he had the com property, which amazing, like takes 20 lines to define a com property or whatever, right? Or a Qt property, again, you write a bunch of lines just to define a simple property. And those are actually very useful and used, as it were. So this is something that we want to start with. Also, I should add, once you have a property like this, you get to think about, I want to add validation before I'm setting the property. I want to validate it with some assert or check or contracts or whatnot. And I can attach those verifications to the simple specification. Now here we have, okay, this of course doesn't work. Oh, it does, doesn't it? Okay, kind of does, right? All right, so in this example here, I have a const eval block. And inside that const eval block, I call this magic function property twice. And as you can imagine, I'm going to define an author and a title, both of type string. So that's the intent. I'm sure there's no mystery here. I mean, it's very clear what I want to do. And the generated code, again, looks like no surprise. I'm going to have a member variable, which is called m_author. Pause for effect. And I'm going to have a getter, which is called get_author. So notice that this author thing I passed inside the property as a string because it did not exist as an identifier when I want to define a property. I want to introduce it. So because it's introduced, I pass it as a string because I can't pass it as an identifier because in C++, any identifier you use already, it must have been defined, right? So then I gotta say m_author and then get_author and then set_author, and I have the usual code for doing all that. And then I have the same for title. So I generated 6 lines of working code from 2 lines of spec, which is in my book a win, right? It's quite nice. So the early observation, which I already kind of alluded to, is we must be able to create identifiers from strings. And just not like that, but by fragments of strings. So you get author, and you gotta say m_author and introduce that stuff as a string. And it's amazing just how much effect this has on the whole design of anything that you want to do with code generation. So all of a sudden we talk about, I need to concatenate strings, and the result of the concatenation, I need to be able to forge into an identifier. And this is something that C++ does not have at all right now. So it's a qualitatively new thing that I'm looking at, right? Identifiers may be introduced, so you introduce a member, or introduce a member function or whatnot, get title, set title, end title, or they can be actually part of the generated code. You use end title when you return it and when you set it and whatever. So you must be able to very fluidly, very easily translate between strings and identifiers. So if you look at the proposal we have, we actually gave a fair shake to all of the splicing models that there are. By the way, I apologize, I'm realizing I'm introducing a word without defining it. Splicing. To splice means to generate code. So there's someone inside some code, and at some point you call some primitive in the compiler that says, boom, splice this code. I don't like the term, just to be fair. I just hate the term. But in a way, I like it because it's easy to pronounce, right? Like reification is a bit more difficult, and the interspersion was discussed, and it's also difficult. So I'm okay with splicing. So there are a few APIs we've been looking at. And one is the spec API. So create the spec of a member variable, and then you specify, it's a specification, so you specify whatever, it has this name, it has this type, it has these attributes, it has this whatever. And then you say, I'm gonna create the specification for a function, and I give it, it's gonna have this name and this return type. So essentially, it's like a little API. Whenever you want to do something, you call a function that's going to complete the specification. And at the end, you're going to have, I'm going to take the spec and splice it into code by means of a compiler primitive. It's easy to imagine such an API. And now we have the code reference API, which has a great advantage. It exists. It has actually been implemented. So if you Google for that thing, you're going to find a site, and you're going to find articles about it and stuff. There is actually a compiler that does code generation for C++, and it has an OOP interface that is a lot like Java. That allows you to, it gives you like a sort of the root of a tree, an AST, and then whatever code you want to generate, you call a function that's going to create a node in the AST. Do you know how many nodes a member function call has? At the minimum, right? So you gotta insert this, you gotta insert like connect this to the method, you gotta have the method, you gotta have the parameters, you gotta have the call, and all of these must be assembled into a little AST. It's extremely, extremely verbose. To write one line of code, you gotta write like 5. A simple line of code. If you start with loops and stuff and ifs and else's and stuff, it's really difficult. So that's the main disadvantage. I don't want to talk about them badly because they did it. And the fact that they did it already has earned them a lot of respect in my book, right? So I'm really sort of grateful, and I'm ashamed to say I don't like their API, right? I'll show a brief example. And then we have like going all the way to the bottom, we have the string injection API, which would go, you have compile time strings, you have the ability to mess with them, and all we'll give you, literally, is one primitive that takes a string during compilation and transforms it into code. And that is actually, that also has been implemented in the D language, as it were, and it is known to work. It is a working API. So that would be the other extreme. Now, the funny thing is, it's very, I mean, code from strings is kind of a very low level, very unstructured idea, right? So it's kind of already a kind of, it's a dirty way of doing things, right? I bet it's like carbon dioxide positive, right? It's not good, right? So it's like, but just intuitively, it's pretty bad. But the funny thing about it, it's, and a colleague mentioned this, you can't use macros. Because they're strings, so inside the compiler doesn't know it's going to be code, right? So it's a string. And when the compiler sees that, the preprocessor has been retired from its job eons ago because it has run in the first step of compilation, right? So the compiler sees the string, it knows how to turn it into code, but whatever it had as a macro name there, it's going to be a name. It's not going to be expanded as a macro because the macro is long gone, the preprocessor, right? So you can't, and you know, I mean, if you have like an assert, it's not going to work. Let's call a spade, right? If you have an assert in that code, it's not going to work, and it's kind of ridiculous. And a lot of APIs use macros for good or bad reasons, but essentially it's not a thing you can really just ignore and say, you know what, yeah, you can generate code, but it better not have macros. That won't work, right? So not good. Last but not least, we looked at fragments, which actually has been a proposal that's been talked about during these like 2 decades we've been doing C++. We've been trying C++ reflection. And there is a bit of OCD with fragments in the sense that they want to be checked very early. So that's the whole premise of fragments. You check the fragment early, which, I don't know, if you've ever been to one of my talks, you know that I have a dim view of that. Right? But don't take my word for it. If you look at any API use of fragments, you're going to see that again. It's extremely bulky, very complex, very difficult to use, exactly because they insist on this early checking. After 21 years of working on it, David came with a great philosophical idea. Right? I mean, I'm not making fun of him because like we're in the same boat, right? All of us. So, and you know, we're looking at how we can do things. So we were at the end of our wits, having gone to hell and back a couple of times, And we're like, David and Barry and myself, we're like, what can we do? Like fragments are a mess, code reference is a mess, that's a mess, the other thing is a mess. And what is a good way to represent C++ code prior to generation so you can generate C++ code from it? And the answer is kind of in the question. There is one way to generate C++ code, which is from C++ code. So if it looks like C++ code, it's going to be very easy to generate as C++ code. So once we had this fantastic insight and we are armed with it and dangerous, we had enough tools to change the game with P3294. If you Google for it, I think you'll find the Toyota car part. If you Google for it in C++, probably you're going to find it, right? You know how it works. So let me make a little detour, not detour, let me just make a little soapbox here. Let me climb on a soapbox and say, I don't think C++ ought to acquire yet another sublanguage. We have macros, we have C, we have C++, like OOP, right? We have templates, C++. We have variadics, completely different sublanguage. Like the rules for variadics are unlike any other rules in C++. We have exceptions, not to mention completely different rules. We have concepts, yet another, right? So we have a bunch of sublanguages kind of thriving inside C++ awesomely. And I don't think it's time for yet another one. And I think the best sublanguage to express code to be generated for C++ is C++. Right? And that takes us straight to string-based code generation. It just, by simply following, you get to, it's like, this is like I think, therefore I am. Right? It just, if you know how Descartes got to there, he got it by a process of thinking step by step, and he said, the only thing I know is that I'm thinking, then therefore I exist. So this is pretty much the whole thing about reflection as well. So now we're going to improve on these strings to make them less unwieldy and be able to use macros with them. And what we're going to use, define and use a new kind of literal, which is going to be called token strings. And you have a token string, and it's pretty much like a string, but it has C++ tokens inside. Let's take a look. Let's create this T1 object, which is caret caret and open embrace. That's the opening of a token string, or token sequence, as it were. They're interchangeably used. So we start this token string, and then we say A plus comment B, and we close it. And that's going to contain 3 tokens, A, plus, and B. The comment has been removed. Why has the comment been removed? Yes, please? Yes, because that's actually the compiler knows its code, the preprocessor knows its code, and therefore it's not going to be removed. It's not a string. Thank you very much. It's not a string. The preprocessor is going to be like, I'm going to go through it, and I understand strings in C, but this is not a string. Therefore, I'm going to see that as a comment, and I'm going to dutifully remove it. So we are left with 3 tokens. If there's a macro in there, again, it's just code. It's not a string. So the macro is going to be expanded during preprocessing, right? So we don't have a fancy string as much as code that is yet to be used. And it's stored right now in T1, right? And it turns out that to simplify, I have a miss. That's kind of, okay, so after comma, what do you think the surprise type would be? I wanted to massage it elsewhere, and I messed up the slide. So what is the type of a token string, you think? It's going to be std meta info. Like everything in the reflection domain is, if we have interpreter style, everything that deals with reflection is std meta info, and we go with that. Inside, the compiler knows that it's actually a token string and it's going to process it accordingly, but as far as the interface is concerned, it's like Python. Everything is an object, right? Everything is an std meta info, right? Now you can actually create a token string that has no meaning in C++, like this T2 guy. So we have incomplete expression essentially. We have a plus equal parentheses. How many tokens do we have? Thank you, 3. So I have 3 tokens, but essentially it's unclosed parentheses, and it's kind of odd. But actually, it does happen when you generate code. You want to kind of store a partial expression, and then continue it later and that kind of stuff. So it's something that's reasonable. All you need is to pair the braces. And last but not least, if you try to actually have unpaired braces, that's not going to work out, and you're going to have a compile time error. And then you have concatenation, comparison. Everything is going to be token level, not textual. So you can have white space inside of such a token sequence, and the white space is going to be normalized, and no problem at all. It's just like regular C++ code where white space does not really matter. Now, when you want to actually manipulate such a token string, remember we had this, we want to manipulate, introduce strings into generated code and concatenate them and create identifiers like mTitle and getTitle and setTitle. And therefore, you need some escapes into these, inside these token strings. And the first escape we have is \paren. And that's going to say, I'm going to expand this expression. Like when you print something, you have interpolation, you just print the expression, you're good. And then we have a more interesting one, which is ID, which is concatenate whatever these expressions are and create an identifier out of the result. So it's a kind of a very controlled, very limited, very careful way of generating identifiers, right? And last but not least, maybe I want to expand the token sequence into another, and I just say tokens, and I expand it into another, so that way I can grow token strings from other token strings by embedding them inside. And okay, once I have this big token string that it's ready for action, what I do, I call the maybe ungainly named qInjection function. I give it some tokens, and it's going to inject it as code into the current declaration context. So you're inside the const-eval function. Depending on where you called the const-eval function from, that's where the code is going to be generated, right? Getting back to our example, I call property. Property is going to be a const-eval function. It's going to generate some nice token strings. It's going to call qInjection. Twice, I have 2 calls to property. And then at the time this brace is closed of the const eval, boom, I'm going to get the code, and I'm going to get my nice expansion. And that's all there is to it. I hate those, yeah, thank you very much. I hate those DIY shows in which they do something really complicated, like a drywall installation and stuff. And then like the guy says, and that's all there is to it. And I'm like, yeah, sure, I'm never going to do that, right? But I do hope that we are going to do a lot of that. Now let's take a look at property. And a suggestion to the, yes, please.
So I was just wondering for qInjection specifically, like the reason that we're using that instead of the splice operator, that's so we can get this deferred behavior where like it doesn't immediately evaluate, it waits until you exit.
Yes, so the question was with qSequence as opposed to splicing things directly. The reason is, first of all, like most of the time when you created these tokens, you are inside the good function. And you want to say, I want to inject like here, but not here, now, but not here, right? So that's the reason. Thank you very much. So now let's take a look. Anybody from the Microsoft? Please pass this along to as a suggestion for syntax highlighting to the Visual Studio and Visual Studio Code teams. I think it looks nice. Like you like that blue and stuff, right? The blue and green. So property, and now I suggest that you squint a bit and you say this is actually almost like C++ code. So I have property; it's a const-eval function, the good things, and I have qInjection at the beginning and I have the closing at the end, and everything with the nice colors is going to be the token sequence. And I'm going to say, oh, okay, so I'm expanding the type and I'm splicing it too, because I don't want the type ID, but I want the type itself. And then I'm going to say ID m underscore name. And as I mentioned, if you say ID of a list of things, it's going to put them together, concatenate them, and generate an identifier. So I have my m underscore title, semicolon. So you see the green stuff, folks, the green stuff is C++ code. And the nice blue stuff is expansion, escapes from the normal C++ code with things that I'm interested in inserting that are variable, right, that are not constant. And then I say, okay, so I got my, my member, and then I want to say, give me the getter function, get underscore name, right? And it returns a const type. And it's a const member, etc., and it does what you expect, and similarly for the setter. Now, you know, I should add as a funny example, like std move from a string is the best way to assign, right? We agree? Right? Okay. And now here's the funny thing. Barry Revzin, who wrote this originally, forgot about this, and he kind of took a const string reference and he assigned it, and that's more expensive. The beauty about defining properties is that you have a good library writer define it, and then you don't need to remember it ever. You just say property, and it does the best for you. Right? It does the moving, and maybe the type is not movable. It's going to do a copy. It's going to do a swap. It's going to do whatever the hell it takes by means of reflection to figure out the best way to copy things or to assign things, right? For comparison, this is the best we could do with the spec-based API, the specification-based. You don't have to, you know, I'm seeing people craning their necks. There's no need to actually see the code, but I just wanted to show you it's quite a bit more bulky, and it doesn't look like it's doing what we think it's doing. It's not, it doesn't look like, oh, I see the property. Nobody sees the property, right? You don't see it. It's, let me find it, right? Do we have time for this? No. And actually with the code recons, it gets even worse. So it's all function calls that create ASTs. And actually, I will take the time to show you, for example, append. So this is the method builder, member name, append return, make field expression, make deref expression, make this expression of B. So this dereferenced field access return. That's return M title. So I took these 4 lines of code. I was wrong before, right? I wrote these 4 lines of code to say return and underscore title. So it requires a level of mastery of C++'s subtleties and all the code that's actually generated and not seen that is quite difficult. And now we're going to pop up a level and say, okay, so we have these nice mechanics and token strings and whatnot. And one question is, what would be the killer app here? Where do you want to go from here? Is this enough, by the way? Do you think these primitives that we have right now that I showed you we can implement property with, are they enough? Who thinks they are enough? Oh my goodness, this is like the worst. Okay, this is the worst vote ever. Who thinks they're not enough? All right, who abstains? Okay, so I'm seeing a few people who didn't raise their hand anytime. What's wrong with you people? Okay, so by the way, so Yogi Berra is famous for saying exactly this. And what's the deal with identity? I want to talk about identity a bit. And it turns out, I'm sure I don't need to convince you that identity is a fundamental notion in computer science. Identity of object, identity of functions, identity of things, identity of types. Are two things the same exact thing, or are they two things that are different but equal? Right? And in JavaScript, you have like many more notions of equality, right? As I'm seeing people chuckling here because they know what I'm talking about. Like, you know, it wasn't enough to have like double equal. Triple equal was invented for JavaScript, right? I assume 4 equals are going to come soon. Next version. So identity, are these things equal or are they separate and kind of different entities? And you know, it's philosophically, it's kind of sound thing to worry about and to think about. You know, are objects fungible? Can I substitute an object for another and get the exact same result? What does the exact same result mean, etc.? So, you know, a lot of things to talk about. For example, I don't know, who's heard of Hobbes? Not Calvin and Hobbes. Thomas Hobbes. Okay, thank you. Yeah, okay. So Thomas Hobbes was a very good philosopher, and he took he had a great take on the ship of Theseus paradox. Oh, what is that? You ask. Okay, what is the ship of Theseus? Who knows? Oh my goodness, this is awesome! Like half of you. This is great. I'm gonna board the half of you, and I'm gonna excite the other half of you. So, ship of Theseus is the following paradox. Theseus had the ship. The ship was absolutely famous. It was, I don't know, it was Elvis's coat, okay? It was better than Elvis's coat at the time, right? So, he had the ship. And then over time, the ship got old and started to kind of putrefy, whatever, disassemble, right, dismantle. So, he took every piece of wood that was getting bad, rotten, and he would replace it. And after a while, you had like a ship that had none of the original wood. And the philosophical question is the ship the same? Right? How do you define, like, what's... I mean, you can see that philosophers like these kind of questions. And there's, I would submit there's a lot of very, very, very smart people in this world who just don't want to do math. You know what? Math is not my thing. I gotta find something else to use my head on. So then Hobbes comes and he says, you know what? While Theseus was doing that, an even cleverer guy comes and he takes the wood, the old wood, and he reconditions it. He sprays it with stuff. I don't know. He does. I'm not the DIY guy, but I'm sure there's stuff that restores wood or whatever, right? He glued that wood and whatnot. He took the old pieces and he made another ship from it. And that's identical to the original ship. And now you have two. Which one of these is Theseus' ship, right? I thought that's a funny thing to know. It's an interesting thing to know and think about because I think there's surprisingly quite a few parallels between philosophy and programming. And in our career, I think we're going to deal quite a bit more with philosophy in the years coming in the form of ethics. More about that later. Anywho, this is clear. It's clear. I don't need to I don't need to sell it that identifying, figuring out what's a copy, what's an object. It has been a daily thing for us. Are you creating an extra copy? What are you doing here? What's happening? Alias analysis. You're aliasing this pointer with this other pointer like an idiot, etc., etc., etc. And therefore, let's talk about the identity function. And I can tell you one thing. One good sign that you're old is that number one, you get to self-quote. And number two, you have too many I told you so's. And I hate both. Who has been at ACCU 2008? Okay, I should ask. Who was alive during ACCU 2008? Right? A few of us. I was in project. Okay. So in 2008, I delivered a keynote at ACCU 2008. And the funny thing is, there were no cameras. So it was like between me and those people. And whatever I said has been like that was it. Right? It's kind of interesting to think about that, right? Philosophically. So anyway, so at that point, there was no C++ 11 because it was 2008. I mean, just do the math, right? And I got in my keynote and I said, you know what? We have a problem, C++ community, because we can't do identity in C++ OX. This new C++ with arbitrary references, all the good things, it can't do identity properly. And they laughed me out the door. No, they didn't. They're British, right? They destroyed me on the Usenet. Right? They're nice people. So I got destroyed on the Usenet. And I came with the following. So I said, here's the first candidate. We have arbitrary reference, just transparently passes it out. Who thinks this is a good function? It's a good implementation of identity. Of course, yeah, I bullied you into not raising that hand, did I? All right, we're not done because we have a problem. Houston, here's the thing. Whenever I call identity against an R value, and I assign it to a reference, which I'm very well allowed to, thank you very much, that reference is going to be damaged. It's illegal. Right? So identity does not work. And the funny thing is, everybody thought it worked. back in 2008. And I bet money there's a few of us right now in this room who initially thought that actually may work. And it does work under certain circumstances, right? Unless you use it. Right? So I got some feedback on the Usenet following my keynote, and they said, I don't understand this guy's obsession with identity. Has no use in the real world. What's the applicability? Etc., etc., and etc. So I got pretty much shredded into little pieces, and I kind of said, actually, there is a way to implement identity. And it's a two-body function. And the first is going to bind to references, and the second is going to bind to R values and R value references. And the second one is actually going to return by value. This is the important part of these two functions. First returns a reference, and the second returns a value. And because I kind of overload them, the reference goes to return by reference, and it's good. And whenever I have an R value reference, it's going to go to the second overload, and it's going to create a copy of the thing, which is exactly what I wanted, and identity works. It doesn't dangle, right? So that's pretty nice. But as I'm sure there's no need to convince you of, having a function with two bodies is a scalability problem. You want a function with one body and one signature, right? Especially in the general case. So you sit a bit more, and you get to this other version of identity, which is a lot better because it, number one, has one body, and number two, it works. You say template, and you actually kind of look like return by value. But fear not, friends, we have a universal reference here on our hands, and a universal reference means T here can transform into either a value or a reference. It just morphs as the need comes. Universal references for the win. Yes? You with me? All right. But inside I do something really sneaky. So I say again, I'm going to forward. This is kind of the formal part. The kind of, forward. I'm forwarding the thing just to make sure I'm doing the right incantation here. But I put one more T around it. What's that T going to do? Opinions. Yes, please. Sorry?
It's a
Constructor. Yes and no. You are both right and very wrong. What does T do, Dietmar?
You have it on the slide.
Sorry?
You have it on the slide. You see the move constructor on the hook.
Thank you. So you're also Dietmar? Okay, I'm an idiot. So, yeah. I just told you that T can morph. And this is the kind of the interesting part of it, the magic of it. T can morph seamlessly into either a value or a reference. So if you say T, open paren, something, close paren, and T is a reference, it's going to do nothing. It's just a trivial cast from itself to itself. It's cast from int ampersand to int ampersand. It does absolutely nothing at all. If T is a reference, this is a non-existent cast. It just disappears. But if T is a value type, then it's going to call the constructor call. Yes, please.
Why do you need the T at all? Because in the case that you pass in an R value, the return type is a value type. It is a non-reference type, and I would expect the forward to just construct the return value without needing an additional constructor.
Give me one more slide. Let's go to C++14, and then we say decal type Oro, and it's going to very nicely work and scale up and everything. It's just going to work great, right? So this identity is kind of the perfect identity function. It just works. And actually, it turns out that if you know how to do this identity, you know how to fix min and max. Because as I'm sure you know, min and max do have a problem. If the press sees this, picture this. They're going to pin it on me because I'm the immigrant. Right? They're going to pin it on me. There's no safety in std min. Right? So just for kicks, once you know how to do identity, you know how to do the perfect min. You just use the CDM and you have your min. So it turns out that after that, identity started to appear in the other places. It appeared in C++20, Timur said, actually, he has a proposal. And he had a proposal which was accepted and said, actually, identity appears in a lot of good places, right? So it's kind of interesting. So I have identity, I have a variety of libraries, you also have identity. And then we have even type identity, which checks whether the two types are identical. So it turns out it's quite a goddamn useful thing to have and pretty awesome to boot, right? So I feel vindicated. What does this all have to do with reflection? Because I'm going to tell you what the killer application of reflection is, and that is being able to write the identity function for a type. This is it, friends. This is it. Being able to assemble a type from pieces, disassemble a type, take the pieces, reassemble another type that's just like it, just like Hobbes did, is the key business of reflection. You gotta be able to explode a type into little pieces. I shouldn't use explode. You should be able to deconstruct a type into little pieces and then take the little pieces and put them back into the same object. And once you can do that, you can do everything. Everything Herb talked about, you can do now. It's not you can do trivially. Because he had this interface example where, he had it virtual to a number of things, right? Disassemble, reassemble, but whenever you reassemble, remember to put the virtual in front of things. Ta-da. I mean, come on, right? It's trivial. He had this polymorphic base example. Again, disassemble, put virtual in front of things, add a few constructors and whatnot, assemble. Ta-da, right? You can do everything with ease. Not only you can do it with ease, right? We have ordered, you can, reconstruct, hashing, whatever you have, if you can disassemble a type to its entirety and then reassemble it back, you can do everything easily. That's why I'm saying it's kind of funny, but identity is the killer function of reflection. Is the killer application of reflection, because once you have that, you have everything else, right? The real challenge is not cloning a type, though. The real challenge is cloning a template. Because when you clone a template, you're operating with that do not exist yet. Right? You operate within an odd space. So clone of some my struct with a few fields and a few functions, yeah, easy. Clone of std vector, that's absolutely nuts. And for example, just as an example, whenever you disassemble std vector and you iterate back through the pieces, you need to remember the same order they were defined in the order in the first place. Guess what? Some compilers throw that information away. So sorry, they'll have to save it. Because order is important, because you define things and then you depend on things that you just defined. That's a problem, right? Maybe you think vector of int is easier, like an instantiation of vector. No, it's not easier. Do you know in place back? It's a template function. It's inside the std vector. Even if after instantiate, you have template functions and possibly template classes inside an already instantiated template. So it never ends, right? So essentially, we gotta be able to implement clone for templates. And to do so, it's the most difficult part. We are not there yet. So everything Herb talked about and everything David is gonna talk about on Friday was about not templates. Everything we need is templates. Right? Taken out of context, that sounds pretty stereotypical, right? So the interesting thing is, the important part, we know where the destination is, and the destination is identity. Thank you very much. So we have an angle of attack. This has not been there's no output yet. So we plan to take a proposal that we already had and build on our P3294 injection with token sequences. David, Barry, and myself, we designed together the token sequences. I think it's a very good idea. And not only, I think it's a very necessary idea. I mean, if you want generation, there's no other good way that we found, at least, right? And we had this John Lennon, Paul McCartney moment whereby it's unclear where the credit goes, who was like the author, who was the helper. It's kind of a collaboration thing, like the Beatles, right? Lennon, McCartney, They compose together? All right. I mean, if you ask me, I think I was Yoko. I'm not sure. But at any rate, it was a great piece of design that I think we have now. And it's a very flexible, very loosely structured mechanism for code generation. It's not as bad as strings. It's not as weird as ASTs. It's just straight the middle. It's a fantastic way to operate with these tokens. Once we have these tokens, the next plan of attack is to say, hey, how about we define a number of primitives that are going to give us elements of templates. Templates are complex. However, they all have tokens. You know, if there's one thing every C++ code has, it's tokens, right? So they have tokens. They have tokens in the declaration. They have tokens in the template parameters. They have tokens in the requires clause. Remember, Nico Iositi is called in this very room. They have tokens in the body, because the compilers must save the tokens anyway, because the template has not yet been instantiated, so they can't really parse the code. They're gonna just save the tokens. Everybody does that. So give me all the body, everything you got about this template in form of token strings. And once I have these token strings, I get to play with them, and then I'm gonna get to do reassembly. Now think of this. Maybe I want to define save vector from std vector, but replace the iterator. And then I'm going to have to do quite a bit of lifting on the functions of the vector, because I have functions that take iterators, like insert. So I have to engineer insert in my new code to take, instead of the vector iterator, my vector iterator. So it's quite a bit of engineering that needs to go into this kind of stuff. Last but not least, let's talk about, I'm over time, but so with your permission, you can go if you don't care about AI. That's a challenge, right? So I experimented a bit with AI too, because we can't not talk about this. Because my 9-year-old wrote 350 lines in 3 hours with GPT.pro, which is an app that teaches exactly kids how to code. Recommend it, it's great. So I'm not sure if I should be happy that my kid is learning or scared, because I think he can tell an if statement from a ground in the hole, but that's pretty much it. He can say, that's a ground in the hole, that's an if statement, but that's about the level, right? Yet he has 350 lines of JavaScript under his belt, and he's very happy about it. Like that, I'm gonna get to 1,000 soon. I'm like, my goodness, this is not a good sign, doesn't bode well. So what's the deal with AI and, because, reflection, boilerplate generation, we can do that with AI. Read the boilerplate, AI can do that. We have editors, there's gonna be smart editors and whatnot. Can we refactor code with AI? Of course. GPT does exactly that, in fact. Whenever GPT has a query, it sends to the AI the whole project and the query. And then it outputs the new project. It just works. So I just tried this very recently, it's like Sunday. I tried the newest ChatGPT model, O1 it's called. Please write a function equivalent clone of std vector, details. It should count calls to each method separately. It did not work. It said, let me generate like 3 methods for it, and the rest are defined similarly. So then I said, can you please write the full code? This is very important for my career. And it worked. In 9 seconds, 450 lines of code. Thank you very much. Working code. I asked about the same about std map. It did not ask me any question. It did not ask me any question. So don't forget, right now, we are at the beginning of everything that's going to be. So I wouldn't bet that a lot of things are not going to happen. I wouldn't bet against AI. Right? They're ridiculous right now compared to what they're going to be. Right? So where's this going? Like, what's the deal? And here's my take. I'll give you like my take on it. I'm not sure if it's correct or not. I think right now, with what LLMs know and do and the disposition they have, the style they have, you should see them as a fellow programmer as opposed to a language feature. Reflection is going to generate you the counting vector every time very correctly and much faster. A query for a reflection for an LLM engine is going to give you a lot of code that is going to be subject to the same scrutiny that a human-generated code, human-written code is. So it's like a colleague, not like a language feature. Language feature is deterministic. Code generated by AI is subject to scrutiny just like a human-written code would be, right? And also, there's the talk about speed. I'm going to talk orders of magnitude. LLM is 100 times slower than reflection. It's maybe 100 times faster than a human programmer, and it doesn't get bored, except if it does. But it's going to be 100 times slower than reflection. Reflection is going to be 100 times slower than compiled code. But you're still good, right? So JITting is going to improve on that and everything. So I anticipate that caching of reflection output is going to be a major focus, because you don't want to generate that every time. And fortunately, it's much easier to cache than template instantiations. I know this from experience with the D language. Caching generated code is a great, it's going to accelerate compilation by a lot. So don't forget, my friends. With procedural, I get to write functions and call them and be happy. With OOP, I get to call functions that have not been written yet. With templates, I can design with types that have not been written yet. And with reflection, I can do whatever the heck I want. Thank you very much. Thank you. We're way out of time, so if you have any questions, feel free to. If you want to leave, feel free to. Thank you. Oh, great. We have 3 minutes almost 4 minutes for questions. Fantastic.
No, the token strings look a bit like format strings. Do we have format strings now?
The token strings look a bit like format strings. They do, but you need a number of escapes that are not typical in format strings. So they're just different. But yeah, there is a similarity, yeah.
Are you going to be able to write the identity function for free functions at some point in the near future, far future?
I don't know.
Because you'll have to reflect on expressions and get into...
I know what you're saying.
Yeah.
I don't know. And I'm afraid to know. Yeah, so if I understand correctly, it's like analyze the whole body of a function. Like, it's there's going to be strong opposition for that.
You can start with smaller pieces. I mean, there was something that came up in an earlier session where one of the, in terms of it was the, where you would want to reflect on an expression that came back as a contract violation.
Right.
That's an error where you want to unpack it a little bit to give a better error message, and you want to reflect on the parse tree of the expression to be able to do that.
That's a very good insight. Thank you very much.
Token strings looks very nice, and I think it reminds me a lot of like quasi-quotes in Scala.
Quasi-code, yes.
Right? Seems
And
like it's a
yeah.
very same idea. Have you looked into that, and what can you learn from that?
I knew of quasi-codes in Lisp. I did not know about quasi-codes in Scala, I'm sorry. But yeah, the lesson comes from Lisp, yes. And they do have pretty much similar mechanisms to everything we talked about here. Yeah.
So it means it's going to work, everything's fine, right?
Exactly. Thank you. Pablo.
One of the criticisms of the string splicing approach was that it's horribly unstructured. Is this not also unstructured?
Is this also not unstructured? It is much more structured than strings, and I'll give you a few examples. When you concatenate strings, you can create identifiers that did not exist, right? You have like ABC, DEF, and you get a new identifier. That's a risk, right? It's a problem, right? With strings, you don't have the macros, right? They're not understood as code until they expanded. With strings, you get to have unpaired braces all over the place and that kind of stuff. So it is quite a bit more structured than strings, while I'll give to you that they're not as structured as ASTs. Yes, thank you, Pablo.
Hi. Will there be any tools to kind of run this generation outside of the compilation script, mainly like for debugging purposes, introspection?
So you want to generate code kind of...
No, like, for example, like I have a binary and I'm debugging an issue. I know there is some issue and I don't understand like what's happening inside the generated code. So I actually want to look at the source code, maybe put a
I see.
breakpoint.
Right, okay, thank you. Debugging generated code. This is like the large topic. I think I mentioned this during the Herb's keynote. Printf-based debugging is very effective with with compile time code. It's actually way like a universe better than debugging templates. Because with templates, you have the instantiation, and you got to look at the instantiation stack, which is not C++ code. It's an instantiation stack. And it looks like nothing C++. It's just a stack. And you got to look at, you got to infer what's happening. You got to, whereas with generated code, you can actually print it during compilation or even at runtime if it were, and you can see what it looks like. As to debugging step by step inside generated code, I think that's a challenging tooling problem. It's a challenging tooling problem. But I repeat, debugging generated code, because this is kind of a hoax going around in some communities, folks. Debugging generated C++ code is way easier than debugging metaprogramming code as it is today. Way easier. And just use printf-based debugging are totally good. Thanks for asking.
So on the slide that you had for meta functions of a reflection of a class template, I noticed at the end there was getBody. How does that work for a class template that has not only a primary template definition, but multiple partial specializations?
I don't know. You know, I was saying during this course that I'm allowed to say I don't know at most 2 times during a talk. The 3rd time I'm dead, but 2 times I'm good. I don't know, and it's a good question. So the question was, just to rephrase it a bit, what if you have a declaration, but then it has like multiple specializations, each with its own body? So maybe you get an array of infos as opposed to a single info, right? And for overloaded function, the same question applies. And that I did think of, and you get an array of infos. Yeah, thank you.
Thanks for your presentation.
Thank you.
I have a question about is that template is a subset of the reflection? So if it is that meaningful that to keep template as well?
Is it meaningful to keep templates once you have reflection?
Exactly.
Thank you for asking. I was hoping somebody's gonna come and ask that. Well, clearly templates are gonna be staying because compatibility and all. But I can tell from personal experience with the D language where they have both for a while that whenever you can, you should prefer reflection to metaprogramming. It's gonna be easier to debug, faster, and overall better, easier to write and understand. But there are situations in which templates are used for not template metaprogramming, such as vector of t. That's not a metaprogram as much as simply a parameterized type. And for those, you don't want to use reflection for that because it doesn't make sense in the first place. So templates do have the role for parameterized types, that's for sure. But for anything that's metaprogramming, I would very much recommend, based on extensive experience, also with benchmarking this kind of stuff. Like you have things like STD numeric sequence, right? Who knows that numeric sequence is actually a primitive inside the compiler? Okay, actually, it is always a primitive inside the compiler. Why, David? Because doing it in, like, you could do it in C++ code, but it would be like 6,000 times slower. It would be like absolutely unbearably slow. And the kind of stuff you can do easily with reflection is gonna make integer sequence look like a, really, really deprecated, really bad. Thank you for asking.
Thank you so much.
Yes, sir.
So, thank you, Andrei. This is a very fascinating talk.
Thank you.
I want to see how far I can push your whatever the hell I want to line.
Heck. I said heck.
Heck. Okay. Guilty as charged. So your analogy of Hobbes imagining putting together a new ship and asking, was it Theseus's ship?
Right.
Could a reflection capability take unsafe C++ code and look into a new language standard and rebuild that as safe C++ code?
Thank you, Mister. I think it's a great idea, and you're really pushing it, right?
Okay.
I don't know. I do presume that there are ways, at least to improve on APIs and signatures. But as far as getting inside code and stuff, that's a much more difficult question.
Mm-hmm. Okay.
Yeah, thank you. That was great. Thanks.
Two things, if I may.
Yes, please.
You seem to. Why would the AI not just produce code using reflection? You seem to assume it would produce the output of the reflection rather.
Yeah. Thanks for asking. Okay. Why did AI not produce reflection? It produced the result of reflection.
Well, not in the current stuff, but.
Right. Yes. AI plus reflection is like an engineer armed with a better API, with a better language. Yes. That's the point. Thank you.
Right.
Yeah.
And then
well put.
You were saying use templates, not reflection. I mean, it seems like a fine line between macros, templates, and types parameterized by types versus source parameterized by whatever. So the reflection could just output vector of this, vector of that.
Reflection could output vector of this, vector of that, but it's based on what model? Like where's begin, where's end? Where are the beginning, where are the seeds of vector?
Well, how do you invoke it, I think? How do you use it as the...
Right, so yeah. So templates are good. I mean, don't get me wrong. Don't remove templates from the language, please, right? Keep them in.
So there's been a lot of talk about safety and trying to make better C++ code. A really neat thing about reflection you mentioned is you could go into a class and make things virtual that traditionally wouldn't. But that's a pretty strict violation of the open-close principle, right? So would this kind of introduction to the language open up a new class of nefarious bugs or gotchas because people are using a tool? I mean, I know we have footguns, that's part of the language, I guess, but what are your thoughts on this and kind of violating open closed? So
let me rephrase. So you're saying I open a class and then the class may have any number of problems in it. Is that the premise?
Yeah, if you reconstruct a class but you modify certain properties about it, it may violate assumptions of that library and things no longer work.
Right. Okay. I'll reflect that back to you, right? When you implement vector of t or sort, right? Presumably t was not properly designed to be stored in a vector. Maybe it uses its own address or whatever, and it's not movable, but it's not, advertising is not movable, or maybe the iterator is wrongly implemented, or maybe the comparison is wrongly implemented. So all of these are yes. With reflection, however, you get to make fewer assumptions because you actually can investigate the API, the interface, and adapt to it. For example, Nico Yosutis had this talk, and he mentioned this, these things about ranges not being filter not working properly, and a variety of things. And with reflection, we have the luxury of being able to say, hey, let's look at this type. Let's look at the primitives it has. From the primitives it has, we can assume certain invariants, right? You're not blindly going in, right? But you're saying if it has begin, end, operator, brackets, and whatever, size and whatnot, empty, then you can assume it behaves like a range. And the user who wrote the reflection code is going to be assuming that. So you're still assuming things, and I totally agree with you on that. And I totally agree that you can use reflection poorly. But the real opportunity there is you can use reflection to actually fix and adapt things that were not working well in the good API, in the previous API. Sort of a good one-liner about reflection is you can actually do copy pasta and modify coding without the guilt, right? Because this is literally what you do. You copy the code somewhere, you mess with it a bit, and you output it, and you have copy pasta code, but it's generated in a very structured, very careful way. Thanks for asking. Thank you very much, everybody, again. Have a great conference.